All right. Okay, so everybody got it? So you just unzip it. Basically, on the model one, you will be seeing that it is having four files. Okay, cat and then body one and brass, and then there's one assembly, Autodesk Inventor assembly file over there. Okay, before you open it, right, you download, extract it first. Then before you open it, let's create a new project first. Okay, we're going to create a new project and the Inventor over here. Okay, last week we created a project chapter 1. So why not today we create another new project? Okay, that is for chapter 2 for good practice. So I will create a project. So I will name it as chapter 2. Okay, save it as the place that you would like to save. Once more time, I will save it at my D drive. Okay. Oops, at my D drive. Okay, in my D drive, I will going to create another workshop folder. So I will call it as the workshop chapter 2. If you want to save it at place, it is completely all right. Okay, so I will be doing that. So now they'll be clean. And then later we drop our file into that particular location. So we can segregate things and files in a more tidy. Okay, so this one last week I already demonstrated, so I will go a little bit fast from here. So finish. So now I have chapter 2. Okay, so now you can drop your file into that particular location. Okay, for example, now in this folder, I created my project just now. And then the file or the model that you download from my file tabs, you can basically put them there. And this is this is the correct way when the time you are using Inventor in the industrial to start project to manage your file, so you don't mix up everything. But if let's say you have a server at your working place that they also purchase the server software called the Vault, then the management concept will be another story. Okay, but for single user that you manage your file, then you may want to establish some collaboration personally. Then this is the way to manage it. Okay, so everybody have your chapter or your project, and then you also download the file that you're having there. Okay, I give 1 minute for this. Okay, if you are facing some technical problem in terms of online, or you are having technical problem that you don't know where's the resources, so while I'm talking, you are looking for someone to help you. Mr. Okay, a student called Sharon, if you saw the name Sharon, you'll be helping me, okay, for that. Yeah, I can see that raise his hand over there, okay. And my slide, I think I also included his name over there. Okay. So anyone facing any difficulties to manage this? Okay, if no, then now we check our project. We know that there is some files inside, so we just open it and we open our assembly. Okay, we open our assembly. So this is what we are going to have for today to assemble this. But I'm including the so-called assembly file over here. It's just for your reference. Okay, it's just for your reference. Now I would like to show the slide what we are going to have for today. I changed a little bit the content for today's workshop, because originally you were seeing that it is assembly, drawing, as well as presentation. But the drawing, I found that maybe one workshop may not enough to talk about. So today I will just talk about the exploded wheel on the drawing. Okay, in detail on the 2D drawing. So the next, we are going to have it in the next week workshop. Next week workshop, one of the topic I bring it forward, it is the content center. Supposingly content center, it is next week topic. I bring it forward over here. So next week, I will talk a little bit more about the drawing. But today's drawing, I will just talk about exploded wheel and how to prepare BOM, bill of material. Okay, so that's what we are going to focus for today. Okay, next, this is what the model that we have, okay, over here, and we are going to assemble it. Okay, and then we are going to use the content center to call out what are the standard part the Inventor offer to us, and then we will learn how to do the exploded wheel under presentation, Inventor presentation, and then how to import the exploded wheel into the drawing, and then to prepare the part list. Okay, so this is the Inventor presentation environment. So we're going to do this later on, and then to create some animation and then export it to the drawing or export it to the as a video file. Okay, if you are working, then you can pass it as like marketing tools to it. And then we prepare the drawing. The drawing, this will be just the assembly drawing. Okay, so drawing have two types generally. One is the part drawing, another one is assembly drawing in engineering perspective. So today we talk about the assembly drawing first, which comparatively a little bit more straightforward and simple. So over here, assembly drawing, we will learn how to create a part list or BOM, the bill of material, and then how to import it from the presentation, the snapshot view from the presentation, and then create the exploded view, and then how to do the label, or here we call the balloon over here. Then later on, we will talk about the I properties, whereby it is the identity of each part, and then how these properties are going to affect your part list or your bill of material. So that will be for the agenda for today. Okay, so now we close this first. So this one is just for your reference. Later we are going to have this definitely, okay? Later we're going to have this as our final product. So now we close it first. And I would like you to open all the single part file, which we are having 3 over here. Okay, so we open the cap. And then we also open the brush. Of course, you can open it in one single selection, okay? But open it one by one, just make it a little bit more fundamental. Okay, open all the 3 parts. And you can see them at the bottom, the tab. Okay, 3 files also active. Okay, if it is too fast or you feel that somewhere you lost, you can just drop a message over there. Okay. Okay, 1 minute for this. Okay, so okay, we have some message over here. During the assembly view, I was not able to see the nuts and the yeah, the bolt and nuts we will be getting it from the content center because they are standard part. So they're part of the agenda for today also. Okay, Zain. So that's why I purposely did not include it. So we can understand how to get it or extract it from the content center. Okay, so now if we are having all this file together, and now I would like you to click new, and then we use metrics because this part is a model based on metrics. So click new, we are going to create a new assembly file over here. Okay, we are going to create a new assembly file over here. And we will select standard and then MM. Okay, select standard MM. There's many of it. We are going to touch on the welding. Okay, I think it is the last workshop, okay, for this series. And then today we will touch on using the drawing also. If you use AutoCAD before, then you know that this icon is AutoCAD. So what we have created in the drawing, basically it is able to direct being open in AutoCAD. And then we will use this also later on, the presentation. Okay, so now we will select this. Okay, when this is being open, normally I would, and I enjoy using this arrangement. You can see that there is an icon up there. Okay, they say this one. Okay, so if you click that, they are going to help us to arrange our view in this way. If you're having this, so maybe we don't need that, so we can just close it. Okay. So this is our part and all this. If you feel that you don't like it, so you can still see that there's an icon there to maximize that view, and then we'll back to like one single. Okay, so we can have that. And if you like to have a little bit more arrangement to list all your part and also your assembly environment, you can also come to view and then arrange in the way that you love. So I would like to arrange in this way. Okay, under view and then arrange it. In assembly, this arrangement is very helpful. If your part is not a lot, like here we only have 3 parts, 1 assembly. But let's say you're doing a design, you have 100 parts. Using this, of course, it is not practical because you have, wow, maybe your computer will hang also. So depend, but this will be something that very interesting. You can have a better and a clearer view. Okay, so I would like to drag my part one by one into the assembly environment. Now understand this concept. Okay, understand this concept. Assembly itself, it doesn't have any content. It's just like a container. You are putting the file into that, or your single part file into it. Okay, even though you put it into it, so the part file doesn't belong to assembly also. It's just a container. Okay, so that will be the issue. Just now I passed the file to you. You see that I zip it. There is one assembly file. And then there is also having 3 parts. So just now you download the part from the file tab. So using this, basically the concept is this is just a container. So they are containing these 3 files into it. If you only pass this file to your colleague or to your friend, then your friend and your colleague open it will be empty because the part file not following. Okay, so that is the concept of assembly. So now I would like to drag and drop my file. So when I want to drag my body first, the body one, so I click that window, and over here, so I drag it in. But sometimes we drag it in, they might not so ideal, given the view that we want. So we need to rearrange them, okay, for ourselves first. Then later we can manually set the home view for it. Okay, so drag, you press this, the window, and then you see the body that, then just drag them in. Same to my brush, I will also drag it. Okay, certain CAD software you may directly drag the part, okay, from here, then it is possible, but too bad, Inventor doesn't offer that. So you have to click, okay, from the design tree to drag that part. Okay, of course, if you're doing this, you feel that, okay, this is one of the things, but a traditional way to place the file, okay, now I maximize it. Just now that is drag and drop. You open all the window. But let's say you want to do in the traditional way, you can also use place, okay, at top there. In that, so there be a few of it. So later we'll touch on this content center. But now let's say we are using our part. You click, they will lead you to the project. So now you can see that create project is very important. So to lead you to the project, and here you also can select the file or the part that you want to put in. Okay, so now I select the CAD. They will preview it to you. Okay, then you can drag. And of course, one single part, you can drop it multiple times. You can try select that part and then use the conventional way, Control-C and Control-V. Copy, paste. No problem. You have one single part, doesn't mean that you can only place it one. You can place multiple times. So now we don't need that, we only need one. Okay. Okay, I want to switch a little bit my view because this view doesn't have the edge. So I go to the view, visual style, I will make it with edge. Up to you, okay, up to you. Okay, before we do anything, if this one you already finished, so let's save it first, because right now we haven't saved our assembly file. Okay, so here we already have one, which I passed to you. You can save it in another new name so that you can use it. So now I may be saying that this is chapter 2, okay, assembly. Okay, name it the name you like. Okay, just don't overwrite this. Okay, don't overwrite this, which I passed to you. So now I save it. I can see that the name is there. Okay, how to manage assembly environment. Now, same way, if you rotate, they will be giving you something like this. Okay, together. Okay, which style, view style? I use shape with edge. Up to you. Okay, but I think using this one, I feel more comfortable. Okay, I don't like it is without the edge line. I feel very ghosting. Okay, so I would like to have it in this way. Okay, under view, you can always switch for it. Okay, let's manage assembly first. This is very important. Okay, first thing first, all this part is freely draggable. Besides the first part that you drop in. The first part you drop into the environment, they will automatically seeing that you will see a pin over there. This is the first part we drag in, right? Unless you're not following me, you drag other part first. But I drag the body part first. And you will see there's a pin over there. The pin over there is mean that that part is grounded. So you can see other part is freely moving, but this is not. And you will see there's a pin over there when I try to move it. So this part is grounded. Okay, grounded is mean that they fix at that position. And this is a correct way to do so. Why? Try to imagine when you try to assemble things, you must have a base first. Okay, you must have a base first. Then after that, you do the things. Okay. Okay. So, or else if you don't have a base, so everything is moving around. You will find that you will not able to successfully assemble the things, either in the real world or in the virtual environment. So if this one, you don't have a ground item, you will find that no matter how hard you try, they will not give you a good assembly later on. So by default, the first part you put in, it will be grounded. But of course, we still can manually do so. You can see that if let's say this part is grounded, how we know it's grounded besides looking at the item? You right click, you see there's an option grounded. If you uncheck it, now this part is movable. Okay, and you see the pin it is disappear. So ground it, then ground. If let's say this, you don't want this ground, you want this grounded. So now this is grounded, so others move. Okay, so there is some of the option we can have. But I still like this part, body is grounded. The other two moving freely, no problem. Okay. Nope, this one for I haven't ground. Okay, grounded. Okay. So you can see that the pin, and now I ground it again, so there's a pin over there. And you will see there's a square bracket at the body there, black dot. So which means this part is no longer movable. But the white dot or negative, that means the part is freely moved or partially freely moved. But cut the story short, they are allowed to be moved around. Okay, now if you pressing home button, okay, or F6, which last week the short key. So F6 is give us back to the isometric view. Okay, but I don't want this as my isometric view. I don't want this as my home. Okay, I would like to have this view as my home. In this way. Okay, but now if you press F6, okay, if you press F6, last week we talked about the hotkey, right? Then they will bring you here. So now we want to redefine our home screen. Okay, because this is home screen that we have. So now you adjust nicely, that is what the angle you want to have. And then right click over there. Okay, you set current view as the home screen and fit to view. Okay, you adjust it and then at that corner and then you right click. Okay, actually you right click over here also possible, but I think here will be better. Okay, and then you select set current view as home screen and you want to view it, fit to view. That means every time you do it, you press the home button, they will give you the zoom all view. Okay, that means they will fit your whole part of it. So now if I check this, and now if I'm pressing the home button, this will be my new home view. Or F6, also possible. So now I change the home view. Assembly, this is very common because when we drop our file into it, every part file we might be modeled it from a different angle. So when they all come together, they might not give us the view that we want. So we need to redefine it by ourselves. Okay, so that is where we are having. So continue to save, Control S. And now if you try to rotate, so all the part, they will rotate by themselves. Sorry, they will all rotate together. And now I would like to have something that it is rotate. Let's say this part, a single part rotate by itself. So you can use something from that position, free rotate and free move. So now I just want to rotate this part. I don't want other parts follow, only this part. So I click, and I click this part. Now I only rotate this part. Okay, to the angle that I want. Escape, they will return. Or free move, only this part. So not moving the other. Okay, basically over here, the free move or the free rotate is for you to, okay, so-called every single part that you would like to arrange by yourself. Okay, so we can try on that. Okay, so now I rotate this and just want to show it. You can see that these brass, they are not just a cylinder, but you can see that there is a tube underneath. Okay, there's a tube underneath. So if let's say you just moving, so they all move together, okay. But if you are using free move, then there's only one part, okay, for it. Sometimes free move, they may work together in with free rotate. Let's say you try to imagine you have a lot of parts. They may be saturated in your screen. So maybe you are taking from a screw over there, and then you just want to move it near to rig to adjust a little bit and rotate it so that you can assemble it. Then this tool will be very useful. Okay. So now we want to assemble it. If you refer to just now, okay, move two parts together. No. Okay, you can only select it. Okay, only one. Okay, so now we try to assemble it. We look at just now the sample or even the drawing. So we know that the brass is the center of it, and then after that the cap on it. But you can see that they are having a gap in between. Now another thing is they are having a tube. The issue is you will think that, okay, now this, they are having a mechanical hole, and here also have a mechanical hole, if you can see that. Okay, you can see that. So during the assemble time, you might be having a question. Okay, you may be having a question. This tube will be insert this point or insert this point. Okay, will be insert this point or insert this point. Because you just looking at it, you may not know about it. If you are the designer, of course, you know the size. Okay, you can see that the size definitely is very different. Okay, so the traditional way is you open that part and look at the dimension. Okay, you open the part, how they do it in a single modeling. But there is a more convenient ways to do so. There is in the inspect. Okay, there is a measure, and the hotkey is M. Now this one very important because when the time we want to do measure, we want to do it fast. So there may be no so-called luxury time every time we want to go to inspect and click measure. But now I just click it. Later I will use the hotkey or the short key M to do the measuring. So now I measure it. I will measure this first. I will want to know. Now I am not a designer. I am just doing the assembly. So I want to know this tube outside, what is the diameter. So I will click this face or this edge, also no problem. So I click the whole face. Now it will tell me the area and also the diameter is 8 mm. Okay, and if you want to have a new measuring, so you press M again, okay, and then you can select the inner one. So you can always do using this measure to check a lot of dimension, even the area, okay, of it. Okay, even the area of it. So now I want to check the diameter, okay, for this outside. So I know that I need a mechanical hole, which is 8 mm diameter, and then insert it. So now the next thing is, this one is having 8 mm or this one is having 8 mm. So now I can measure. So I look at this. Or this one is 6 mm. So I know that this tube is not for it. Okay, because 8 mm cannot insert into 6 mm. And I will look at it. This bottom, oops, sorry, make it fresh again. So now it is 8 mm. So I know that this tube will be inserted here. Okay, rather than that. Okay, so now I close my measure. Later, want to call it, we use the hotkey M. Okay, we use the hotkey M. And now we're back to assemble. Now the first thing, how to put them together, we use constraint. Constraint is a very intelligent way to do the assembly in the Inventor. Okay, hotkey again is C. And now they have a lot of features offer us how to do the assembly, but sometimes we don't need to care about it unless our case is really specific. Why? Because when you select the face of the geometry, they will automatically detect and select the proper one for us. So now we take a look at it. So I want to have the center line of this tube with the center line of this tube. Okay, mesh together. So very intuitive way is, now I just select that face so that the center line is being shown. So I click that. Okay, they selected that center line. And then I will select this center line also. Now you see that they will be select the features that is suitable for this assembly. Then you will see the word, sorry, you will hear the sound, okay, if you open your voice. Okay, so I will apply it. Now this one fixed. So now we cancel it first. So we only fix the center line, but they are still rotate. Because rotation doesn't violate the center line constraint or fixing point. So if you look at it at the front view, you can see that this part, if you're following my one, they cannot drag away from the center line. So this center line I already fixed. So you try to drag them, they cannot be dragged away from it. But they can still up, down, and rotate. Why? Because you haven't fixed that yet. So in assembly, you need to always imagine and visualize. Am I fully fixing it? Okay, they might need 1 or 2 constraints just to make that part into the position. Okay, so now I will use measure again. Okay, I will try to measure this because I know that they will cap into it. I want to know the diameter or the radius or the size of this. So now I look at it. Oh, 24 radius. Okay, 24 radius. And I'll try to measure it. Okay, inside this 22. How about the outside? Oh, 24. Diameter 48. So radius 24. Correct. So 24 for the radius. So this is 24 radius also. So I know that this is going to rest over here. Okay, so I use measure, I'm pressing M of it. So now in the constraint, so if you want to click the icon, use the hotkey C. And now I will select this as a center line and select this center line. So now they will be placed at that position. And now it's not trackable, so it's fully fixed. Okay, save first. Okay, everybody following? Is it okay? So next thing is, of course, we put a cap on it. Okay, we put a cap on it over there. So if you look at the slide, so the cap, so they will place on it. Okay, they will place on it. But they will not fully cover it because you can see that there's a gap over there. So we check the dimension again. Okay, let's check the dimension again. Now I use M. I want to see this. Oh, this one is 24. So case very obvious because this is 24 radius. And this one is 24. We also know it. So we know that they will rest on it. Rest on this. So the cap rest on it. Not rest on this one. They rest on this. Okay. But we're also seeing that there is a mechanical hole here, and this is the mechanical hole. So very obvious, these two holes, they will in the same alignment, center line. So then I will use constraint. Now I use hotkey. Here I use hotkey, fast. So select the center line first, and select the center line. Apply. And then even though it is still movable, up, down, and also rotating, but they are already aligned in terms of the center line over there. So all we need to do is later we kept that. Okay. So F6. Okay. So we move it fast. So that no problem. If let's say you would like to select the center line of it. Okay. So not the edge. One more time. Not the edge. Okay. Select the face of that curve so that they will detect the center line of that curve. So now I will select this, which is also 24. So I'll put them in. And now you shall see that they are fully placing. I will save it first. So assembly in Inventor, in a way, kind of intelligent. From years they developed the software. In the first version, when they roll out doing all this, you got to do it very manually. They may not able to auto detect it, but now they're able to do so. So you select the geometry, okay, like cylinder, cylinder, circle, circle. So center line they will match, face and face, and then they will match, and then we get the job done. But you must know the dimension in a proper way, so you know which is which to match them. Okay, so using the measure, that will be very convenient. Even though you are the designer, but when you design 100 parts already, you also forgot about the dimension. To open back the part and look at the dimension, it will be very troublesome. So using measure will be very effective during the assembly. Okay, you can also use inspect to check Are there any interference or not? Because sometimes 3D part and 3D part, they may interference, but we don't know the interference because internal. So we can use that to check. Okay, so now I use interference, so I will check this part and also this part first. So see that they got any interference or not. So they say no. Okay, they say no. Okay, and then also we check this part and also this part. So no interference as well. Can, okay, Zayan can, no problem. So just show it a simple way first over there. Oops. Okay, I try to demonstrate. This one you need to follow. I just try to demonstrate. If let's say there's interference, how they will look like. So now place one more part over here. Okay, and I am trying to separate. You can see that interference right over there. You can see that because in 3D model, the software normally during this modeling time they don't care about the interference. Okay, you can see there's interference over there. So if you're using inspect to check, check this, also this. So now they will tell you there's an interference happening. So in a complicated assembly time, doing the checking will be greatly reduce your mistake. So or because sometimes if you don't check, we may not see the internal interference. That only we know about it during the real item assembly. After that, people say they cannot fit in. So then there will be a lot of extra work need to carry out. Okay, so this one just for demonstration. You can see that on your design tree, all the constraints just now you develop, they are in the relationship over there. Okay, they are in the relationship over there. Or each part as well, you open them, you will see that the relationship. Okay, that happened. Okay, assembly can be very creative. Okay, up to you how you want to do it. For example, just now Zain is asking that if I don't want to use center line, can I use the other way? Of course, it's possible. So now I try to demonstrate that. So just now I'm using this center to center. So now I try to delete it. So now I make it, they are still freely moving. So just now I'm using the center line of this and also the center line of this. But we also can use face. Okay, I use constraint again. Now you look at the face, they have two types. One is saying that the face and the face, they stick to one another. Another face is they are parallel, same level. One is stick on it, another one is parallel to it. So the picture can give us a very straightforward illustration and explanation. So now I just want to have this face and this face, they are in the same level. So I can choose this. Now this one you got to define it manually very clear. So select this face and this face. So now I can see that they are in the same level. I selected this. Okay. But after you select this, you will find that they are just not able to rotate. Okay, but they are still moving up and down. So then maybe you need to have another extra thing. Then this face, okay, I still need to fix it. So then I have one extra over here. Okay, so nobody make a rules how to do the assemble. It is up to you how you do it. Yes, anyone is having other questions from here. And you also can check the internal. Let's say you want this cap to turn to become transparent. You can right click and select transparent. Or the hotkey is alternate T. So now it becomes transparent. They are there. Okay, you can see they are there. But they become transparent, so you can view internal. Okay, and you see the icon also change to become the water cube transparent. So you turn it off, turn it off. Or this one, I can also turn it to become transparent. So I use hotkey alternate T. So you can see the internal. Okay, or both, no problem. So this for checking also will be very useful. So now I don't need this. Turn it back. Alternate T. Okay, no issue. Next, we will talk about the content center. Okay, content center. So content center is those parts, they are already standard. They follow the code. Okay, they already have a code. They already have an identity. So you're using the code. People will give you the part with all the exact dimension. So you do. Normally we don't model it. Normally we don't so-called even to put it into our engineering drawing. We will just put the code over there and telling them we want to buy this fastener, this nut, this code of it. So we take a look at the content center. Now I want to put the bolt and nut. Okay, so because I used that before, so you can see that my library open. Okay, place from content center, you'll be seeing that they are all having all this part. They are so-called standard part in the market. Okay, of course, bolt and nut will be the very common one that we're going to have, but you can see that they have other things. Okay, you can try to explore by yourself. Now today, we take a look at the fastener first, which is quite kind of common to us. Okay, bolt, nuts, pin, rivet, and also the washers. Now we call out the bolt first. Okay, if you look at the drawing, we basically have the bolt, okay, at the bottom. Okay, screw up, and after that on top, two nuts to tighten it. Okay, so you can see that there it is. Even though they give us a dimension over here, this is where I take this from the very old fashions book. Okay, they give us some dimension, expect us to model it, but now we don't model it anymore. But at least we know that they're looking for it is not a round bolt head. It is a square bolt head. Square bolt head. So you can see that the word over there, SQ, square. So we will get the square bolt head from the Inventor. So we take a look at the bolt. Okay, you will look at it, countersunk and already I see the square head over there. Okay, I see the square head over there. Double click, and they have a lot of standard. Now the standard, of course, right now it is up to you as the engineer, what your company is using, or what your customer is requesting. So this library is open, you still can move your part, or you rotate it. So just rotate it at the bottom and see that. See there is two. Okay, place for us to place the screw, the bolt over there. So now we just simply get one standard. So let's say I want to use the IS. Okay, so double click. Now I click the standard, and you may be asking the question, I haven't specified the dimension and the sizing, right? We need not to do so in Inventor. All you need is you selected the standard already and you go and move to that particular position. Now they will auto detect the sizing, and then after that, they will give you the correct size over there. But of course, later we can still manually adjust a little bit. But at least the size of the screw and all those things, based on what you model, they will give it in the proper way. Okay. So now you can see over there. So I move it. Okay, I place it there. Now click. So now when the time you click, they will be auto scanning your whole model, saying that there's another same size of hole. It is over there. Shall we also insert it? If it is yes, by default is yes, whereby they already check the insert multiple. But if let's say you don't want, you just uncheck it, then they will only insert at that particular position that you want. Okay, but now we want it. We want to insert multiple, the same size. So I will check it back over there. Okay, simple one first. That will be in this manner. Okay, due to time constraint, if more detail about the other standard, how it is how to distinguish them, maybe we can talk during email or chatting. Okay, you can select your standard, okay, accordingly. So now I will click OK. So now I have two, and I escape to end that. Place two. The screw is still not fully constrained because why? They are still rotatable. Normally we don't fix the screw, so we just let them rotate. Okay. Now you can see that the screw is too short because if you look at our drawing, there supposedly is overshot. Give us some overlap over there. So now I would like to use the view, sectional view. Okay, I would like to use a sectional view to view internally, so that I can adjust the screw, okay, in a better view. So I will check the half section. I will select the face and slowly adjust. Okay, you just click on that pointing arrow. Okay, pointing arrow over there. So adjust your cutting plan until you see the screw over there. They will not cut the screw because to them, the screw is from the content center. It is not part of your file. It is not part of your model. Okay, so you can see the design tree also. This is your model. From content center, the icon is different. So that's why when you do the sectional cutting, they are not cutting the screw. But that is good. At least we can see in a better manner. So now I can see that the screw is not long enough. So I click OK. So I have some view. Okay, now one of the tips in 3D modeling, unless it is really necessary, normally the mechanical hole on the part, we don't model spiral because that will already consume a lot of memory. We will indicate that if spiral is a tap hole or not a tap hole. We will indicate that in the drawing. Okay, we indicate it in the drawing. If you are using hole features, last week that I'm talking about, not just using an extrude cut with a circle, and then during the drawing time, you will have a lot of benefit. Okay, so that's why you see that they are not fit, right? Seems, but according to the standard, they are there. Okay, they are there. So no need to worry about it. So now I want to adjust my screw, okay, in a longer manner. So I right click. You say change size. Okay, right click, change size. If you don't like that, you can also do it here. Right click, change size. Okay, you can even do it together. Oh, I don't think we can do it together. We have to do it one by one. Okay. So change size, call out the menu now. You can adjust the length accordingly. So here they already show that you have a thread, okay, a thread over there. Okay, and using M10 for this size. So we cannot manually key in also, they have a standard for it. So we use the standard length based on this code, IS2585. Okay, so I'll try to find it. If it's too long, you feel that. Okay, so if you click apply, don't click OK. If you click apply, then you will still back or return this window. If you click OK, then your window closed already, then you need to call it out again. So every time you just want to test it, try it, so just click apply first. So I say 100, maybe it's too long, so I tried 90. So I think 90 is slightly okay for it. If you feel that this standard is not what you want, for example, this thread length is too short, then you might need to choose another standard for it. Okay, so you can see that there's other information over there. Okay, so I'm happy with this. So I'm going to do that for another one. So Sam, I use 90 for it. So now I successfully customize a little bit my bow under this family standard. If you're choosing other standard, okay, then you adjust accordingly. But in our scenario right now, just make sure that you are having some thread head is overlapping, because later we want to put in the nut to tighten the things. That is the concept of this assembly. So my one is okay, so I'm happy with it. You can adjust yours one right now. Let's see, there's a message. No message. Okay. Okay, so I will continue. Want to finish the content center, then we take maybe a 5-minute break. Okay. So now I will do the same thing. I will want to look for the nuts for it. So Sam place from content center. Okay, Sam place from content center. Only this round I am not selecting the bow. I will going to select the nuts. Okay. So the drawing saying that is a hexagonal nuts. Okay, I think it's a hexa. So then we choose the hexa. Okay, rather than the others. Okay, select the one that you would like to use. Just now my one is using IS standard, so I will look for the IS standard back over there. So I fill it. Okay, if you are using your standard, so look back that family of it. Okay, so I will just, I don't want to get a very big one. Okay, I think this will be same thing. So once you select it, okay, please over there. And then again, they detect the same. So multiple, insert. So now I'm having it. And if you want more, so continue from there. Okay, continue from there. But now they cannot detect, because again, they only scan your model. They don't scan the item from the content center. So that's why now I place on the content center. My screw is placed on another screw. Oh, sorry, my nut is placed on another nut, whereby it is from the content center. So that's why they cannot detect. So we might do it manually. Okay. So done. And if you feel that you also want more overlapping out, okay, so you can still adjust. I think to me right now is okay. Okay. So if you feel not satisfied with the length, so you can still change the size accordingly. So the nut is still rotatable. So all this is rotatable. So we don't fix it. But if you want to fix it, of course, you can fix them. Okay, you can either use the fast way to ground them, okay, or you use the face that is parallel to your model face, also no problem. Now I will turn off my sectional view because everything is good. So back to the view. In the sectional view here, I will just end section view. Okay. Once again, okay. So I delete the nuts here. Okay, so I will place again from the content center. Okay, look for the nuts. For the nuts, we use hexagonal nuts. So this is your library. Then hexagonal nuts. Look for the standard that match your screw or your bolt. My bolt just now I'm using IS, so I will also choose back IS family from here. Okay, I have a few of them, so I will just choose. Just now I choose which one. Okay, now I choose another one. Okay, I choose this. So, okay, so just go and place. Okay. So now I select the edge, which is my model. So they will scan my model and find that same size. So multiple insert will be activated. So okay, so they will insert it, just like the bow just now. But now if you want to place another top of the model, okay, they will not detect multiple insert. Why? Because what I'm selecting the edge, okay, they are from the content library or the content center. And Inventor will not take any file or any item from the content center as a 3D model. Okay, so that's why they not detect. So you have to manually do so. Okay, just roughly touch on that. As you can see, the preview that is suit you the position. Then just click OK. So you see, we don't model fastener bow and nut. You look at the library, there's a huge of them. They are all standard. In the real world, when you are working in the industrial, nobody will going to so-called make their own fastener unless they have a specific purpose of your machine. You need a very customized bow and nut whereby the market did not or does not available those sizing. Then you need to customize and make it by yourself in-house. Then you may need to model it. But if let's say you are taking it from the market and people is saying that, okay, what size you want, what standard you want, those are already being fixed, being documented, being well documented. And why not we still want to model it? So nobody will do so. Okay, we call those standard part. And now I end my sectional view. So everything is good, and I save it. Okay. Shall we continue or need a small break? Basically, I would like to continue because 2-hour workshop, I need to do it a little bit, not so intensive, but just don't want to waste the time. Okay. So there is no problem. Okay, so this is what we have. And now let's continue. Okay, we get into, so this one we got it already. So now we get into next thing is how we already know this too. So now how to do the exploded view under the Inventor presentation. Okay, under the Inventor presentation. So this one we can still leave it open, active. So we click new, and we are going to create a presentation. Also under matrix, standard IPN. Okay, Inventor presentation. IPT, Inventor part, Inventor assembly. Only this one is drawing because they follow back AutoCAD. Now Inventor and AutoCAD, same company called Autodesk. Okay, so that's why they will let their files able to talk to one another. So that's why the drawing over there, you can see that is still there. But they also have the Inventors. Okay, this is the IDW. Okay, you can make a choice, but from my experience, you using this later, you convert it to DWG AutoCAD file. They don't have any issue at all. Okay, so now we use the standard IPN and then we create. So now we have a presentation here. Now they will ask you to place your assembly. Straight away, they will ask you to place your assembly. Okay, so we choose the assembly, which just now we model. Okay, so then I open it. You can adjust the size of your storyboard. If you're first time using it, your storyboard might be in this way. You can try to expand it, no problem. Okay, you can try to expand it, no problem. Okay, again, every time you drop assembly, they are giving you the visual style that doesn't have the edge. So every time I also want to open it. So now you try to press F6 if you already set your home view just now. Here they will follow. Just now I redefined my home view. And right now we no need to do so. Presentation kind of attached to assembly. Now you see the relationship of the files. Okay, assembly, they link it to your part file. Presentation, it link it to your assembly file. Of course, drawing, they will link it to either the part file or the assembly file because we need to create both type of drawing. Okay, everybody in the presentation and successfully insert your assembly here. Okay, so now we do so-called disassemble. Okay, we do a disassemble. And I would like to disassemble the screw first. So we use tweak component. Okay, we use tweak component. Now I will be doing in this way. I would like to have this screw. Click. And then you will see that they are having 3 pointing position. Now I want the screw is assembled up. Okay, so I will select the Y-axis. Can you see that? So I select it. Okay, because I want it to go in this direction, vertical, up and down. And now I need to key in the distance. Okay, if I put it 150, they go down 150. But I want it to go up. So then I will put negative. Now they go up. Okay, go up. And this moving up duration time is 2.5 seconds. You can adjust that. Okay, you can adjust that. But now we just make it simple first. 2.5 is kind of good timing. So I adjust up 150. So I click OK. So now I'm having that. And you can see that there will be a storyboard 2.5 seconds created. So if you roll it back in the beginning, so you play, Okay, take 2.5 seconds to move to the position 150. Okay. Okay, so now I want to continue. Okay, so I will, okay, I will click to the end of the storyboard and continue from there. And now I also want to adjust this screw up, the nuts. So I'll tweak. Okay, I click tweak, they will come out this interface, and I select that. And I also select that position. I want it to be the same level. So negative 150 as well. So the duration also the same. So now I click OK. So now you can see that another one. If you try to roll back again and play, so they will this and then this. So just like the video, you can see that. Okay, so now you'll be seeing in this way. But you can also adjust. Okay, you can also adjust. Now you'll be seeing that this screw first, and then this nut, and then this nut. But how about I want two nuts go up together? Not one by one. I want two together. So in your storyboard, you can put them together. Now this one is really require a little bit multimedia. Okay, so now I'm putting that together. So that's mean when the time they play, now they will together. Okay, so if you able to do so, okay, now save it. Okay, save first. So normally I will follow the assembly name, but I know that there are different types, but I follow the assembly name so that I know that this presentation or this exploded view is for that assembly. So I don't rename it. So we set as the same. But looking at your tab over here, they are still having all your part and also assembly active. Okay, so now I will do another two nuts over there. Tweak. And just now I select nut one by one, but basically you also can select two nuts together. Okay, one more time. Huh? Okay, so pressing Control, then you can select both nuts together. Okay, both nuts together. So just like normal way when you want to have multiple select, right, in window environment, you're pressing Control. So here also the same. So you can select both, so they can move together. So now I click that. Now I don't want to be negative 150 anymore because they will collide. So I will make it to 100. That will be enough. So then okay. And so now there will be something look like this. This first, and then follow with it. Now you can do the assemble in this manner for all the other parts and make it to the presentation, the animation that you feel nice to you. Okay, for me right now, I just do it fast. Right? Okay, I just do it fast. You can do it your way first, but just make sure that you're able to assemble. You're able to so-called disassemble it. Okay, so now for example, now I want to see my nuts all together in the beginning, but one is just elevate to 100, another elevate to 150. So now I put them together in the beginning. They start. So I will having something like this. Okay, I'm having something like this. Okay, I prefer to see it in this way. So now I will tweak it, the component of my bow as well. So I will also select both together, and then I will select the direction. Select the direction, and going down. Now they point up. So if I want it to go down, I will start with negative 150. Okay. And I also don't want them to so-called happen after the nuts remove. So I want them to move together in the fastener. So I will move them all in the beginning as the starting. So then I have something like this. So I want them to assemble or disassemble it together. So I make them the same position starting point. But if let's say you don't want that, you want them to step by step, then you can also move, okay, the animation accordingly. Because this one is for you to produce an animation. Nothing to do with your exploded view later in the drawing. Okay, nothing to do with that. Because exploded view is static, not animated. So as long as later on everything is exploded, is disassembled, then it's fine. But in terms of animation, you can play something like this. Okay, so now I will do for the others. So I will tweak the others. So I tweak this up. I also don't want to collect. So maybe this direction up, I will give 75. And okay. And the brush go up 50. Okay. So now you'll be seeing that. So disassemble the screw and then the head of the cap, and then after that the brass. Okay, if you want them together, then you can move them together as well. Okay, if you don't want, then you can still move them back. Okay, end of this and then end of this. So storyboard, a little bit multimedia, but I don't think that will be a problem to all of you. Okay. First. Okay, and if let's say you are happy with that, so I'm happy to put them together. So that's me, I put them together as a starting. So you can create a video. Okay, you can create a video. Okay, so I think they only have two file types for us, AVI and also the window media video. Okay, up to you where you want to save them. The only thing I don't like over here is the file location. They did not automatically detect the project, our project location. Anyway, you just save it where you want. So I will just save it, okay, as a window media file, and then I try to put them at my, okay, my video here. Okay, so then I produce it. Okay, if you want to adjust, make it more high resolution, adjust it. I just want to make it quick, so I don't want to make it too high in the resolution. Because just for demonstration. So okay. And now if I go to my video folder, double click it. So this is the video. Okay, this is the video. And now you can see that my video is not so perfect because I'm using that current view to do the recording. They are recording is based on your current view. Okay, based on your current view. So you can see my current view like this, and is like this. So they are same as it is. So if you would like to have the full, then better you open your exploded view, F6, and then you start recording, create video in this way, so that you can have the full of it. Okay, so they record your current view as it is. Okay, but anyway, that is how you produce the video, the animation, your exploded view accordingly. So everybody have a video for yourself. Okay, so I can see comments, so I will proceed. So now we know how to produce the video. You can pass it to your marketing people, or you can just want to communicate with other people rather than just talk, ask them, okay, look at it, how to assemble it, how to disassemble it. If you give to technical people or even customer, so this is how they disassemble, what are the part is over there, okay. Now, we want to create drawing now. Okay, we want to create drawing. But before you create or import it into the drawing, something like this. So this one, okay. So before we make them into the drawing in this way, you need to create a snapshot view first, or else in the drawing later, they might just randomly pick it for you. What is the meaning of the snapshot view? That means later in the drawing, what are the view that you would like them to present? Okay, what the view that you want them to present? So I definitely want a full exploded view. So now in the full exploded view, I will create a new snapshot. Now you can see that my snapshot view is empty. Okay, so I want to create one. So you can see that I view one, which is a full disassemble. Okay, so you can see that. Oops. And I also want to have another view that is they are assembled. So I will be turning back. And then F6. Okay, I want this view also. So here I will also create another new snapshot view. So I have view 1 and view 2. One is exploded, another one is fully assembled. Now this will be helping us later in the drawing. So you need to create that one first. If you don't create it later in the drawing, they will randomly picking some of the view. Might be coincidentally you are getting it, but sometimes you might not getting it. So better define the view that you want to put into the drawing first under the snapshot view. Okay, so now I'm having it already. I will create drawing. So now we click new. Okay, we click new and then we choose the drawing. We choose ISO. Okay, we don't create the AutoCAD file first. We create the so-called the Inventor drawing first. Okay, under metrics, select the ISO drawing. So create. So don't worry, all your assembly, your presentation, all your single part are still active. Okay, so now it's the drawing. So this is ISO standard drawing, so-called style of it. How to make that? Next week we talk about more detail about drawing environment. But today we just want to see how to do the assembly, exploded view, and then the bill of material or part list over here. So now we do a base. Okay. When the time you do a base, by default, if let's say your presentation is open, your Inventor presentation is open, then they will detect the presentation, or else you can still select from it the file that you all open over there. Or sometimes they will list out the file that is from the project. But they will give priority, okay, they will give priority to the file that is open. So that's why I'm saying that in the beginning, sometimes let's say it's okay, you don't close it first. Open it next to it. Which drawing? ISO, IDW. Okay, so do it one more time. So new, under metrics, And then we select this ISO IDW. You can choose this one also, actually. Okay, small differences, okay, in between, but for our scope, still okay. But I just make it proper. Okay, so Sharon, okay. So base, oh, sorry. So now base, so presentation, now you see that presentation, view 1 and view 2, it is the two views that you are created in the snapshot. If you did not create snapshot view, the list over here, they will still have one view, but that view is randomly picked by the system. But now I define it, so I can see that view 2 is fully assembled. View 1 is the exploded view. So you can see it over there. Okay, so now I want to have one exploded, and then later I will also put one fully assembled. Okay, so you can move it. Don't project first. You can see that automatically they ask you to project here and there. Okay, don't project first. We just one view first. So you can move it somewhere over here. And the scale you can adjust 1 to 4 over here. I say no, maybe 1 to 2 will be good. Okay, so having that. Now the style. Okay, I don't need a hidden line because hidden line for the assembly drawing might be not very nice to see. But if you want the hidden line, then you can select that hidden line. Okay, and let's say you want the color shaded, you also can select this. Or else you will have a monochrome. Later we can see the effect. We can readjust back later on. Okay, if you don't want to show the tray, okay, you off later, the tray actually will not be shown. But I think better to have the tray over there. So now I'm having it. Okay, so save it. Okay, I will also follow back the assembly name. Yes to all. Just save. Now they are trying to asking you the link of it. So sorry for it. Okay, if let's say you want to adjust your view, you can right click, edit view. Now you say I want to use this shaded. Okay. So they have color. But if let's say it's printed, then of course putting color doesn't matter. Okay, so if you want hidden line, this is a hidden line, but it's very ugly. Normally we don't put that in the assembly. Okay, so this normally will be the best. So I will place one more base. Now I will select another view whereby it is a fully assembled one. And now this one I want to make it a little bit bigger, so I will give 1 to 1. Okay, I move it here. Okay, so now I have one assembled, another one is a fully. One is exploded, another one is a fully assembled. Okay, for me. So this is how we insert, okay, the exploded view into the drawing by creating snapshot view. You can also create other view, you know. For example, I create a view like this. Example, so I create a new. You can see look like this. So if I back here and I place one more time, I have another new view. You can see that. Push it there, then that's how it looks like. Okay, you can be trying to use whatever that you want over there. Okay, with that. Okay. Okay, so now look at the slide. that we are having. So we are having this and this. So we already know how to make the snapshot view for it, and then how to do the exploded view and import into it. Now next, how to do the part list or the BOM, and then follow with the boolean which is linked to your part list number. Okay, you can see that this part is referring to the body, number 1. So you have only 1, so the body. And then you can see that there is the nuts name. So we have 4, so number 5, so there's the nuts, and then for the end accordingly. Okay, so there's a part list. So now we call the part list over here. Under the annotated, okay, under the annotated, so you will see there's a part list there. Okay, under the annotated, there's a part list over here. So you click the part list, and then they ask you to select the view. Because we have 2, so that's why they ask us to select the view. But we know both are the same, so it doesn't matter. So I will select that. Okay, I will select that view. Because I want it to match to this. I know that they are matching, but sometimes just for safe, so I will select that. So I selected the view. So everything, okay, all this, no problem. So click OK. Okay. Because first time I haven't enabled the BOM features. The first time you're using that. So they will ask you to enable it, so I will enable it. And now that's my table list. They are snappable at the corner. Okay, so I put it at top, this corner. So now I'm happy. Now the part list is also intelligent. They will help you to auto calculate your part. If the parts are the same, you have 4, then they will give you, they will help you to calculate it is 4. If both you have 2, then they will help you to calculate there's 2. Okay, if it's only 1, then they will help you to calculate. So in terms of the quantity, by using this, we no longer need to worry. Last time, engineer, you need to go and calculate. Now, even you're using AutoCAD manual drawing, so after that, you still need to calculate. And then you prepare the part list. If you calculate wrongly, then the extra purchase or the under purchase, quote unquote, then it will be greatly delayed or even cost more on the project. But this one, everything will be just nice over there. Okay, it will be just nice over there. So everybody able to get your part list? Description, because they are coming from our content library or the content center. So the description is also fixed by the library. So we just leave it. But later, I will also show how we can manipulate the part list over there. How you work together with the I properties, just now I mentioned the last topic of today. Then after you call the part list, then now we label it. The label we call balance. Okay, we call balance. There are 2 options. You can auto balance or you can do manual. I demonstrate the manual first, one by one. So manual is you point that part, then you drag it up. Okay, and then continue. Then they will auto detect part number 5. You look at part number 5, or this is the nut. Okay, and then you continue. Let's say I click this, and then right click, continue, or part number 3, or cat. And then this one, and then continue. Oh, number 2. Okay, then. Okay, then you can do that. If you only have, if you only have a few parts, then okay, no issue. But let's say you have 100 parts. Sometimes you don't want to do that. Okay, but at least you know how to do this. Okay, you can manually select it. They will auto match to your part list table. Okay, so now, how to do it in the auto? Auto, if let's say you select auto balloon, first select the wheel first, of course. Okay, selected the wheel, and then you say that how they look like. I want that label around the wheel. Okay, so label around the wheel, and then select, highlight all the component. Then later select the placement. Now you can see the placement. Okay. Click. Apply. Done. But of course, sometimes auto balloon, they might not be so nice to me. Why I say not so nice? Sometimes they are overlapping certain part. Okay, or sometimes you can see that. So you can still manually adjust it, even though you do auto. Okay, try on that. So now, if you get this, you can see that your assembly drawing over here is complete. An industrial assembly engineering drawing, you have exploded wheel, you label them properly, you have a part list, and then you also have an assemble wheel over there. For an assembly drawing, this one is good. Okay, this one is good. For basic, okay, for basic. So I save it first. Okay, anyone not getting this? You can voice it out. So today we able to produce a video. We also to produce assembly drawing, and then we also know how to produce the part list and all those things. Okay, no issue. Okay, no issue. The last topic, how to manipulate the part list or the bill of material. By default, item and quantity, we don't disturb it because this is very important. The item, they match to the label. The quantity is intelligent calculation. So you don't touch it, okay? So now on the part list over here, you can right click. Okay, you can right click, you can edit the part list. So they will call out this to you. Edit the part list over here. Now, let's say I want to add more information. You say that I'm going to add new information, and here they call as a column chooser. So if you click on it, column chooser, then we have all this information over here, and all this information it is under I properties. Where's the I properties? Later we talk about it, but we look at it here first. Okay. Now let's say I want to add in the author of the part. So now you see that this is what already over there. So okay, they may say that I don't want a description. I don't need that, so you remove it. Okay. You can also say that okay now there's the author, and then what else you can look at there. Okay. Okay, you can look at that. So you may say that, okay, who is the supplier? Okay. So now item, quantity, part number. Part number basically is follow your file name. Okay, follow the file name. So and the author, all these things. So okay. So now you see that they change. Apply. So that's that. Okay, so this is how you can manipulate. You can edit the part list accordingly. Now, let's say just now you look at so many properties. author and vendor, all this. So now if I want to fill the information, should I fill it here? You find that I cannot. How? Okay, sometimes some of it can author because I'm the author. Okay, you are the author, you can change that also. But this is not the proper way to fill in over here. You need to use the I properties, which is the last for it. The I properties, when the time you're doing modeling on your single part. Okay, on your single part. So now we go to our single part. We try on the body first. So look for the body over there. Single part. And then under the file, you see the I properties over there. The I, very obvious, it is Inventor. Okay. So that's why many years back when they come out, iPhone, iPad, iWatch, or no, iWatch, Apple Watch, okay, or all those products. I always have an impression, Inventor. After that, I know the Apple product. But iProduct from Inventor, they come first. Okay, but now I think Apple product more, more obvious, more significant. Okay. But cannot change actually all this term Inventor using it. IPT, IAM, IDW, IPN, I properties, and there's more. iPad, ISMD, there's a lot. Okay, but now we go to I properties. Now you can see over here, this is where you fill in the information. So when the time you model, work as an engineer, you finish model, you not just finish model, you need to fill in the information so that when you pass this part to other people, then people will know, okay, not just the dimension of it. Like last week I'm talking about, you model, why you're using step by step, because people know in terms of manufacturing how to do that. And then here also need to fill in. For example, now the author, that's my name, of course, the name I registered, the software they follow. But now you can key in your own name. Okay, but for this part, okay, for this part. Okay, even I can put in company, for example. Oops. Okay, just now we also add in one vendor, right? So project, the vendor. So let's say we are saying that they are coming from certain company supply. Okay, I say that, okay, it's from Siemens, example. Okay, hopefully they won't kill us. They don't supply all these things. And then if you want to give them the link, also can. You can fill in all this information. Later, they can display on your part list. Of course, your part list, you can choose what you want to display. Okay, but they allow you to choose from this window what you key in. If you put in everything complete, then your part list will be very, so-called very flourish. You can choose whatever the information you want. You can even change it anytime because the information is ready. Okay, so day of creation. So who is the engineer? Who is the designer? Okay, so the status of it, the stock number. Okay, all these things you can display. You can even customize it. Okay, and physical. I already mentioned that. If you look at the I properties physical, the material that you choose, of course, you can choose the other material over here. But let's say now this is steel, they will tell you the density, the mass, the area, the volume, okay, the center of gravity, and other initial properties when you're talking about the rotation and all those things. So this one for analysis, this is very useful for analysis. Okay, but now this one is under simulation, so we're talking about modeling here. Okay, so it will be this field, tab. That will be useful. So now I already fill in the author and also the render. So now apply, and I go back to the drawing. So now you see that. So I adjust a little bit the sizing. Okay, snap it again. So now you see. But I only edit the I properties of my body one. So the other no. So now let's say I go to brush. I go to I properties, and then now I fill in the name. Okay, the author. Maybe right now it is not me, other people. Okay, maybe it is Peter, for example. Okay, Parker. Okay, project and then vendor. So then you may see that this is from ABB engineering. Okay, example. So apply. So now they will display that. Okay. So this is iProperties. Just try to take a look at iProperties in every part. What are the information is there? Normally the information to me so many years, they did not really change the content of iProperties, and I find that the information is really more than enough. Okay, so now there's the part list, how you manipulate it, and then how you call it. And last but not the least, for the part list is of course this kind of table. If cannot export, then too bad. Normally they can export, okay, in the Excel. Then you can even pass it to your friend or whoever. They don't have Inventor, but they need the part list. For example, purchase department, they need a list to purchase things, but they don't have Inventor because you purposely buy another license for the purchaser just to open the file. Then it is a little bit luxury. Okay, so normally we pass Excel. So then we export the Excel. We say that this is project. Okay, you name the project. Okay, I say chapter 2. So I say here. So now it is under my project location, Excel. So I open it. So we take a look at it, how it looks like. Quite a graph, okay, but get the job done. To purchaser, the most important thing is they know who should I call, how many you want to buy, what it is, who requests, then will be enough. But depend on your company, okay? Depend on your company. Okay, I think that's all from me for today's workshop. Then we end with iProperties that link to our part list or view of material. Any questions from all of you? Okay, if no questions, so I will also share the evaluation form for today. Okay. So just help me to fill in the evaluation form for today so I can improve from there. So last week I received a feedback saying that it's too slow. So today I speed up a little bit the progress. Difference of parts in the library, yeah, there are a lot of it. Until today, I don't think I know all the content in the content library after 10 years plus using Inventor. Because I'm not going to use all the standard, right? So we don't know, okay? To me, ISO, so very common in Malaysia. When the time I work at Europe, so I'm follow the DIN because I'm working at Holland, so they follow DIN. So these two normally I'm using. In Malaysia, sometimes we're using BSI. Some certain companies still using BSI. Other than that, I don't think I know everything about the content library. Okay. If no further question, I will stop the recording. And thank you for your time.